Okay, good afternoon class. So today we're looking at analytical geometry. Okay, at this point we have discussed already where the equation of the circle comes from, and we have two scenarios. We have a equation of a circle center at the origin, and the equation of a circle is center is not at the origin. Otherwise you can refer to the video in the description box below. Okay, we're looking at example 1, and example 1 is on page . Which page was that example 1 on? Page 189. Okay, we have done this with the group. However, it was load shedding at the time. Okay, so we couldn't record the lesson. Okay. Okay, so this is example 1, and example 1 is on page 189. But this is grade 12 analytical geometry, and this is for exercise. Examples for exercise. Sorry? 1, and page, exercise 1 is on page 190. 192. Okay. Okay, so the first sum says determine the equation of the circle or circles with the center at the origin and passing through -5 and -7. So if that's the case, we have then a circle center at origin and is passing through -5 and -7. So that's approximately there. So as we know, there are two scenarios. You have circle center at origin following a formula: x squared plus y squared is equal to r squared. If the center was not at origin, it's going to be x minus a all squared plus y minus b squared is equal to r squared. The center is your a and b value. Okay, so for this equation here, we just need to calculate your r value. Okay, so we just need one point on the graph, which we do have. We'll substitute that point, which is -5 and -7. Remembering that's an x and a y. So -5 squared plus -7 squared is equal to r squared. So -5 squared is 25 plus 49. Plus 25 plus 49. We have an answer of 74. 74 is equal to r squared. So my equation is x squared plus y squared is equal to 74. Okay. Now we're looking at example 2 on the same page. Okay, here the center is now not at the origin, and it has a radius of 7. Okay, so we got a circle. Center of the circle is at -3 and 5. Of course, has a radius of 7. So in this scenario, we can see we will use the other formula, which is x minus a squared plus y minus b squared is equal to r squared. Okay. So I got x minus -3, which will become positive 3 squared, plus y minus 5 squared is equal to r squared. But we know the radius is 7, so that's going to give you 7 squared, which in turn is 49. Okay. If you want, you can multiply it out for no extra marks, but that is suffice. We accept that as an answer. Okay. The next one, we are told that the diameter AB. So we have a scenario where we are given the diameter. We have a circle. So that is your A, which is 2 and -4. B, which is -2 and 10. So if this is your diameter, we know your diameter is twice your radius. So that is the center of the circle would be the midpoint of line AB. Okay. So to calculate C, it's going to be x1 plus x2 over 2. So it's 2 plus negative 2 over 2. y1 plus y2 over 2, negative 4 plus 10 over 2. Which now gives me 0 and 6, which is 3. So the center is 0 and 3. So again, that's going to follow a formula with the equation of the circle, where the equation is not, where the circle is not at its center. So that will be x minus a squared plus y minus b squared is equal to r squared. Okay. So I'm going to say x minus, remembering that center of the circle is your a and b value. So it's x minus a squared plus y minus 3 squared is equal to r squared. So that will simply give me x squared plus y minus 3 squared is equal to r squared. So to calculate my r value, I'm either going to substitute a or b in to calculate your r. Otherwise, what you could have done was you could have worked out the distance of AB and then divided by 2 to get your r. Or you can calculate CB or CA using distance formula to calculate r anyway. But what I'm going to do is I'm just going to substitute B. Substitute B, which is negative 2 and 10. So we've got negative 2 squared plus 10 minus 3 squared is equal to r squared, which is 4 plus 49 is equal to r squared, which implies that r squared would be 53 units r squared. So therefore my equation is going to be x squared, or x minus 0, which is x squared, plus y minus 3 squared is equal to 53. Okay. That example 4. Example 4 is also on page 198. Okay. So here we are told that determine the equation of the circle where the x-intercept at 2 and 0 and the y-intercept is at 0 and 6 and the radius of 2 root 5. So if you're looking at a circle, we have an x-intercept at 2 and 0 and a y-intercept at 0 and 6. So we got a circle that could look like that. Or of course that circle could look like that. Okay, so we have two scenarios here. And remember that the radius of the circle, of course, is 2 root 5. Okay. So, of course, we're going to follow the formula. We say the center of the circle is not at the origin. So, we'll follow the formula. X minus a squared plus y minus b squared is equal to r squared. Remembering a and b is the center of the circle. Either that one or this here. Okay. So since r is 2 root 5, my formula now reads x minus a squared plus y minus b squared is equal to 2 root 5 squared, which is 4 times 5 is 20. Okay. So here I need to solve for a and b. So what do we need here? There's two unknowns, so I need to use two coordinates on this graph here. So I'm going to substitute your y-intercept first. You substitute 0 and 6, remembering that's an x and a y. If it lies on the circumference of the circle, if the point lies on the circumference of the circle, it's considered as an x and a y. Otherwise, if it's the center of the circle, it will be your a and b value. Okay. So it's going to be 0 minus a squared plus 6 minus b squared is equal to 20. Okay, which gives me a squared plus 6, which is 36, minus 12b plus b squared is equal to 20. Okay, that's equation 1. Then we can substitute 2 and 0 Remembering again, that's a x and a y. So you got 2 minus a squared plus 0 minus b squared is equal to 20. So it's 4 minus 4a plus a squared plus b squared is equal to 20, and this is equation 2. So what I'm going to do is I'm going to set equation 1 equal to equation 2. Okay, so you say equation 1 equals equation 2. So as you can see, both is equal to 20. Therefore, a squared plus 36 minus 12b plus b squared is equal to 4 minus 4a plus a squared plus b squared. We add we cancel out where we can. So I'm going to take 4a over the equal sign. So then 4a is equal to 12b and 36. 4 minus 36 is negative 32. So I divide it by 4. So I'll get 3b minus 8. So this of course is equation 3. Okay. So what we'll do now, we'll substitute equation 3 either into equation 1 or equation 2. Okay. So I just need some space here. I'll just get it. So I'm going to substitute equation 3 into equation 1 or 2. I'm going with 2 since 2 is on the board. So if I see here a, I'm going to replace it with a 3b minus 8. Okay. Or I could have gone with that equation here, it doesn't matter. So I say 2 minus 3b minus 8 squared plus b squared is equal to 20. So that's going to give you negative 3b plus 10 squared plus b squared is equal to 20. So it's going to give you 9b squared minus, that's going to be 60b plus 100 plus b squared minus 20 is equal to 0, which gives me 10b squared minus 60b plus 8 is equal to 0. You can either use your quadratic equation, your quadratic formula, or you can use your trinomial factorization, or you can use your FX991 calculator here. So just program with the calculator. So they give me 10 as your A value, negative 60 as your B value, and 80 as your C, which gives me a B value of 4 or 2. It's 4 or 2. Now to get a corresponding A value, and of course substitute that into equation 3. Okay. So if we do it, you substitute into equation 3, let's just pull this down. We will substitute in equation 3, my A value now reads A is equal to 3 times 4, which is 12, minus 8 is 4. So the one value coordinate is 4 and 4. Or on the other hand, if B is 2, your A is going to be 3 times 2, which is 6, minus 8 is negative 2.
So now says that you guys are going to improve the meeting because other people are using the coordinates too.
No problem. Okay, so the coordinates is going to be 2 and negative 2. Is that correct? Your A value is negative 2. Sorry, the other way around. So is negative 2 and your b value of 2. But have you answered the question? And the answer of course is no. Remember your r squared is 20. My equation now reads, let's pull this down. My equation now reads, first one, if that is the case, then your center is going to be x minus 4 squared plus y minus 4 squared is equal to 20. On the other hand, negative 2 and 2 is your center of the circle. Your formula would be, so I put here, or x plus 2 squared plus y minus 2 squared is equal to 20. Okay. That's how we get the equation, the center of the circle, given that the radius is 2. Okay. Then we spoke about the standard form of a circle, which is a minus x squared plus y minus b squared equal to r squared, and we discussed that a minus b all squared is actually a perfect square trinomial. If you multiply this out, it will result in a perfect square trinomial, and we revised the fact that what we did in grade 11, which was the completing of the square, can come into play. Okay, we discussed that thing. Remember the constant of the it's a perfect square trinomial where the coefficient of the first term is always 1, and if the coefficient is not 1, we must get it to be 1. Okay, and then we worked out the middle term, the third term, by saying the middle term multiplied by half, and it must be squared. Okay, and we went through those examples there. So this is example 1, and this is on page. Example 1 is on page 191. Example 1 on page 191. The question says determine the radius and the center of the circle of the following circles. Determine the radius and the center of the following circles. So we can see that x squared plus y squared is equal to r squared. That is in the form of x. Okay? And this is when the center is at the origin. The center of the circle is at the origin. So the center of the circle, of course, is 0 and 0. And of course, that is your r squared. So r squared is 12. The square root thereof is going to be 2 root 3. Okay? That sum is fairly simple. Let's look at number 2. Okay, so in number 2 we got x minus 6 all squared plus y squared is equal to 100. Okay, so the center of the circle, of course, is going to be the additive inverse of 6. Negative 6, which is of course 6. And of course 0 there. Because if you got y squared can be written as y minus 0 squared. Okay, and as you can see, that's going to be 0. Whilst that is r squared. So r squared is going to be 100. The root thereof is going to give us 10. Okay, so we got the square root of 10 and the center of the circle being at 6 and 0 there. Okay. Steerman, you okay? Hey! Where do people come from? What? Guys, not serious about your maths. But anyway, in number 3, example 3 on page 191, we are given x squared plus 8x plus y squared minus 3y is equal to negative 6. Now to get the center of the circle and the radius, we must get the circle first in the form of x minus a squared plus y minus b squared is equal to r squared. We need to get it in that form first. So we need to complete the square here first. Okay, so we got x squared plus 8x plus a number to complete the square with, plus y squared minus 3y plus, of course, some constant to complete the square with, equals negative 6 plus the first number plus the second number, of course. Okay, remember in an equation, we add 1 to the left hand side, I must add it to the right hand side as well. Whereas in an expression, if I add something, I must subtract it as well. Okay. So what must be added to complete the square with here? It's going to be b, which is 8, and 8 times half is 4, and 4 squared is 16. And on the other hand, if you've got negative 3 times half, is 3 over 2, and 3 over 2 squared is going to give you 9 over 4. But you're going to say, but mustn't that be negative? Yes, it could be negative, but negative squared will result in a positive solution anyway. So there's your perfect square trinomial. Okay? So that will give you as x plus 4 squared plus y minus, it will always take the sign of the middle term, 3 over 2 squared is equal to negative 6 plus 16 is 10, and 10 plus 9 over 4 is going to give you 49 over 4. Okay. So what is the center of the circle? The coordinates, of course, the additive inverse of that is negative 4 and positive 3 over 2. Okay, and your r squared, of course, is 49 over 4. So your radius, of course, is going to be 7 over 2. Okay. Look at example 4. In example 4, you will see that the coefficient of x squared and y squared is not 1. So we said if it's not 1, we must get it to be 1. Alright, so what we're going to do first is we're going to divide by 2. Alright, so I divide throughout by 2. I'm going to get x squared plus 3x. I'm writing that in front as well. Plus y squared is equal minus 5 over 2 is equal to 0. So we're going to take negative 5 over 2 over the equal sign. So it's going to be x squared plus 3x. That will be a perfect square trinomial. So I must add a number to complete the square with. Plus y squared is already a perfect square. There's no other y there. Okay? We'll get 5 over 2 plus that same number I'm adding. Okay. So what number must be added here is going to be b times half, which is 3 over 2. And it must be squared, which is 9 over 4. Okay. And of course, there is my perfect square trinomial. So now it can be written as x plus 3 over 2 squared plus y squared is equal to 19 over 4. So what's the coordinates of the center of the circle? Negative 3 over 2 and 0. Whilst your radius squared is 19 over 4. The square root thereof is going to be the square root of 19 over. Okay. So with that you should be able to do exercise 1, and exercise 1 is on page 119.